Okay, so the schedule for today, we'll have a warm up here momentarily. Then we'll do a couple of quick notes. You'll need out your identities pink sheet. Then we're going to take a formative, and then you'll have time at the end to work on finishing up the two, because I handed out a second one for you today, the two worksheets. Okay? So there should be a 5-1 trig identities practice and a 5-1 trig identities worksheet. And why we didn't just combine them into one, I'll never know. I'll clearly blame myself because it's probably me. Yep. And then looking ahead, next week, Thursday, is going to be your test on 5-1 and 5-2. Okay? So, for a warm-up today, please simplify that. Go for it. So cosecant is 1 over sine. Cosine is cosine. Cotangent is cosine over sine. So then this becomes 1 over sine of x minus cosine squared over sine of x. Can I combine those fractions? Yep, because they have common denominators. So then that becomes 1 minus cosine squared all over sine. Anytime you see a squared, you should automatically think some kind of an identity. Okay? Is there an identity for 1 minus cosine squared? What is it? Sine squared. Sine squared divided by sine then is just sine. So that whittles all the way down to just sine. Questions, comments, concerns, clarifications, soliloquies, haikus, rants, monologues. Okay. Take out a calculator. Doesn't matter as long as it's a scientific type of calculator. And I would love for you to compare on your calculator the sine of 20 degrees to the cosine of 70 degrees. The sine of 42 degrees to the cosine of 48 degrees. And the sine of 68 degrees to the cosine of 22 degrees. Contrast, compare. Oh, make sure that your calculator is in degrees. Am I right in saying this? Yes? Both of them? The sine of 20 degrees and the cosine of 70 degrees are both equal to 0.342. Okay. Okay. So I can say that all the way through. What do you know about 20 degree angle and a 70 degree angle? They add up to 90, right? The sum of them is 90. What do we call two angles that sum is 90 degrees? Well, it is complementary because it makes a corner. 90 degrees makes a corner. Okay. What's the other one? Supplementary, that makes a straight line. That's the sum. Okay. All right. So these are complementary angles. And that will always be the case. If you'll notice that over here on the unit circle, it starts at root 3 over 2 and the cosines, and then it goes down to 1/2. Well, the sines start at 1/2 and then go to root 3 over 2. Okay? They're always opposite of one another on those complementary angles. So because of that fact, we have 6 more identities for you. And these are numbers, I want to say 12. Yep, 12 through 16. Oh, yep, 12 through 17. Yep. 12 through 17. Very easy to know when to use them because you will either see 90 degrees here or pi over 2 minus the angle. Then you know that you're dealing with a complementary angle. Okay? All right? So with that being said, then, and those being out there, let's simplify this one. The sine of negative x times the secant of pi over 2 minus x. Sine of negative x, can I simplify that one in any way? Using which identity? Using identity number 2. So this one would become negative sine of x. Not a fan of that sign there. Let's just go like this. Okay. The second one, secant of pi over 2 minus x, that to me would be number 17, correct? So number 17 says that if I have the secant of pi over 2 minus x, that is the cosecant of x. Yes? Okay. Cosecant then is 1 over sine of x. Negative sine of x times 1 over sine of x would be that, which that simplifies to be negative 1. Okay? You try this one. Sine of theta, nothing can happen there. Tangent becomes sine over cosine. Sine over cosine times cosine is going to be sine. Sine of theta minus sine of theta plus sine of theta, that's a lot of sines of theta, is just sine of theta. Yes? Good stuff? Good stuff. Any questions? Try those two. I'd make this top be 1 minus cosine squared, right? Because really it's 1 minus cosine plus cosine minus cosine squared. So that's just 1 minus cosine squared. And that then is all going to still be over sine. 1 minus cosine squared is sine squared. Still over sine. Now it's just kind of like the warm-up problem where it ends up being sine of x. Agree on the first one. Anybody need some more explanation? Left one. Only the left one. Right one you got. In your hand right now. You didn't even know it. Agree? Okay. This one becomes secant squared of y minus tangent squared of y all over secant of y. Secant squared, again, if anything's got a squared, probably got some kind of an identity to go along with it. Secant squared is tangent squared plus 1. Tangent squared plus 1 minus tangent squared is just 1. So this becomes 1 over secant of y. 1 over the secant of y is cosine of y. Cozy. Questions on that? Okay. So the next part then, so if we go back to, go all the way back to here. So we did our warm-up, done. We just did our notes, done. So now we're going to take the formative. It's only a 2-question formative, and we are not going to correct it in class today. I'm going to correct it later on tonight because sometimes we get a little mad at you because you just are so worried about doing it, you don't understand why you got it wrong. Kind of deal. So we're going to give you a little pause in between. And then after you're done with the formative, you can put it back in your grading teacher's basket. And then we will, you have 2 worksheets that you can be working on. Most of you in this one got it on 2 separate sheets because of my mistake. But you 2 got it on 1 sheet. You got both worksheets on front and back. Because of my mistake. Okay? So those 2 worksheets then will both be due on next week. Okay? And I posted the answers to them on the